Let's talk about the ones that you know first. So you know what a minimum is because, minimum means the lowest, right? So the minimum number would be when I list all of those numbers in ascending order, meaning the smallest is on the left, the biggest is on the right. The minimum is the lowest number. And then the maximum, would be the highest number, and that makes sense. And we already know that the median is the middle number. So we just go in and we find the middle number, or we average the two numbers in the middle to get the median. Okay, so the two things that you probably don't know yet are the first quartile and the third quartile. And the definition of the first quartile is that it's the median of the lower half. So basically we split the numbers in half and we just look at the lower half and we find the median of that half. That's our first quartile. And then when we've split the numbers in half, we look at the top half and we find the median or the middle number of those, and that's our third quartile. So let's look at this in actual real life. So here's our quiz scores again, and we've got them in order. So the min of this would be 3, the minimum number. The maximum number would be 25. And again, those numbers are really helpful because they tell us a little bit about the spread. And actually it's called the range of the data set. So it tells us how far apart these numbers are, because just because the median is 12.5 in this case, that doesn't mean that we can't have a number as low as like -57 and +100. But the range from 3 to 25 tells us how spread out our numbers are. Then we knew our median. Okay, so this was the max. And here's our min. We know our median, our middle was right here, right? Because of 1, 2, 3, 4, 5, 6, 7, 8 on one side, and then 8 on the other. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. So our median was right here. And in this case, our actual median is 12.5 because it's halfway in between those two middle points. So what is the top half of our data and what's the bottom half of our data? Well, the top half of our data is right here. And the bottom half of our data is right here. So this is the bottom half, and our first quartile is the median of this bottom half, or the middle number in the bottom half. And then our third quartile is the middle number in our top half. And you can think of the median kind of as our second quartile. And if you think about the word quartile, it kind of sounds like quarters, right? So we've split the group into quarters, right? So the first quartile is a quarter of the way through the data. And then the second quartile, or the median, is 2/4 of the way through the data. And then 3/4 of the way through the data is our third quartile, and then our max. So let's find the first quartile. It's the middle number of the bottom half. So this has 8 numbers in it, which means I'm going to go into the middle. So I'm going to go all the way in, and I get the middle numbers. So these are my two middle numbers. I average those since I have two numbers. They happen to be the same in this case, but a lot of times they're not. So I average them. 6 plus 6 divided by 12 is 6. So my first quartile is 6 because it's the middle number of the bottom half. Okay, then the middle number of the top half, or the median of the top half. Okay. So we go in just a little bit and we get that these two are our middle numbers. So the third quartile is the middle of those two, which is 15 plus 16 divided by 2, or 15.5. So this is our 5-number summary right here. Let's get rid of some of this ugliness. Okay, so our 5-number summary would tell us that our minimum is 3, our first quartile is 6, our median is 12.5, our third quartile is 15.5, and our maximum is 25. The reason we care about the quartiles is because they tell us, again, how spread out our data is. And it also helps us find outliers. There's this thing called the 1.5 IQR. You don't need to know what that is, but basically it tells us when we can qualify a number as an outlier and when we can't. And so these quartiles help us find how far out a data point has to be considered something unusual or strange.